The accuracy of any sunscreen product measurement is dependent upon a good product application technique. It is critically important that the sunscreen product is uniformly distributed over the entire substrate surface and an optimum film thickness is achieved. Gaps or holes should not be present on the sunscreen film, as these will adversely affect the measurement accuracy. The surface topography of the HD plates can be seen here, showing the pronounced peaks and valleys of the plates. The sample amount and spreading technique should be such that an optimum film thickness is achieved on the substrate surface. The optimum film thickness is not only important for accurate SPF measurements, but is also critical in achieving accurate measurement results with Calipa, Bootstar, and FDA methods. In preparation of the plate, it is essential to have a proper amount of product based on the roughness of the plate. With Helioscreen HD6 plates, 1.3 milligrams per square centimeters of sample needs to be deposited, which is about 32.5 milligrams of product on a 50 millimeter by 50 millimeter plate. A negative displacement technique is recommended for dispensing the sample on the plate. With this technique, insert the tip of the pipette with a dialed-in number and slowly release the plunger to fill the pipette with product to ensure that there are no air pockets. Place the pipette onto an analytical balance and close the doors down as tightly as possible without touching the pipette, and then zero out the balance. Remove the pipette, discharge the product, wiping the tip clean, and reweigh the pipette. If the amount of product is not within 0.4 of a milligram from the required amount, adjust the dial on the pipette to increase or decrease the amount of sample until an amount of 32.5 milligrams plus or minus 0.4 milligrams is achieved. People that are new to the procedure might desire to use a positive displacement technique to ensure the correct sample weight. The positive displacement technique is usually not favored for highly evaporating products because the product evaporates as it is deposited onto the sample plate. To use the positive displacement technique, pull the sample into the pipette and zero out the plate on the scale. Deposit the product starting in the center and work out in a spiral fashion to ensure that the right amount of sample is deposited. When dispensing the product on the plate, it is important to cover most of the plate area with equal size dots. When using a linear row pattern, deposit 5 drops in 5 rows as quickly as possible, working about a 1/4 inch from the edge of the plate first to create 2 parallel lines. Then split the difference between those 2 lines and come back to split each of those adjacent lines. All the drops do not have to be exactly the same, but it is important to get them as close as possible. Once the sample has been deposited onto the plate, wet the finger cut with the sample to make sure no product is absorbed off the plate. The finger cut should be glossy, showing that it's not dry. Finger cuts come in small, medium, and large sizes. It is important to choose a right size so that a very tight fit on the finger is achieved. Creases on the finger cut can remove the sample from the plate, resulting in incorrect results. Quickly use a linear technique in a Z fashion to spread the product as quickly as possible in 2 directions. For the Calipa method, after spreading in a linear fashion, a pressurized circular motion helps to grind the product into the troughs of the topography on the plate. After the circular motion, it is suggested to spread in columns oscillating back and forth until the product solidifies on the plate. Once it starts to dry, the process is complete. The Boots method suggests using just linear motions to spread the product under light pressure to quickly spread the sample. Always remember for any spreading process to stay away from the edge of the plate. The film now becomes much less swirled and more uniform as the spreading process ends. Most people in the industry prefer to hold the sample spread plate against a background to verify the uniformity of the spread. Once uniformity is assured, store the plate in a safe, dark place for 15 to 20 minutes, allowing it to cure. Another technique that has worked quite well for many is depositing the first drop out of the pipette on the center of the plate and work in a concentric ring pattern quickly. The sample is dispensed out from the center to spread the product as uniformly as possible, finishing in the corner of the plate. If there is a little extra sample left, typically depositing towards the middle of the plate works the best. Wet the finger cup prior to spreading in between subsequent plates and spread the sample using the blotting technique. This technique works well, especially if one has put an undercoat of petroleum jelly under the product, which is typically recommended when using inorganic products. With the blotting technique, move the dots to the undeposited areas of the plate, working as quickly as possible, quickly blotting in rows. Once the plate is covered, apply more pressure to the top emulsion to press the product down into the troughs of the topography to achieve a uniform film across all the peaks and valleys of the plate. This technique is good for depositing inorganic sunscreens that might be comprised of both zinc oxide and titanium dioxide. This method is very helpful in keeping the product from going off the edge of the plate. When the spreading is complete, check the sample uniformity before putting the plate into a safe dark space for a minimum of 15 to 20 minutes for curing.